Hello everyone, my name is Pratik, and in today's tutorial I will be using COMSOL multiphysics software to model drug transport through skin. Uh, for more detail, you can go on to this one of the blogs which was posted on COMSOL website, which is on like designing effective transdermal drug delivery patches with simulations. So you can understand like this is the patch and containing some drug, and then you model how this drug will be transported into the skin using the COMSOL multiphysics software. So basically you would be aiming for some graphs related to the flux of the drug and in what time it is going into the tissue, whether it is going in or not, and what all different factors needs to be taken into account while modeling this. So let's go back to the yeah. So for the modeling of this type of system, we would be using the transport of species in porous media module, which is available in COMSOL. So I will just start with opening the COMSOL. So when you open the COMSOL, let me start it from the beginning. Let's say new file. We go forward with the blank model, and this type of window will pop up, and then here we add component. Let's say we will initially model it in 2D, so you just click 2D model, and then go over here, add physics. So since because skin is a porous media and you are putting patch on the top of the porous media, so for that we would be using the module called transport of derivative species in porous media. I already used it before, so it shows in the recently used. But you can go down in the chemical species transport, and here you will find transport of derivative species in porous media module. You can just double click on that. Yeah. So this will give you like this will come here. So now first we will go on and create a simple geometry of the patch and the tissue. So for that, let's go into geometry. We take the length in, let's say, in millimeters, yeah, or let's say centimeters. We have to be very careful with the unit that we are choosing in, which is a good thing with COMSOL because here you can predefine the units, but in the different other softwares like Abacus, and there you have to you cannot choose the unit, but you have to be very consistent with the unit throughout the modeling. But here like COMSOL is interface is good at like the at units and all, because whatever property that you put, you can just it will show a unit at the end, like what type of unit is expected from the user. So we will just first go forward with creating the geometry. Let's say we'll create one rectangle of 1 by like width of 1 centimeter, height of let's say 5 centimeter. Build object. Sorry, let's say the width it's let's say 10 centimeter, height is 2 centimeter. Build on. We'll see. Came here. You can for the skin you can also sketch. You can also use the sketch option. You can just build your own sketch using the polygon. Let's say you come here, you draw the model of the skin. You will see in the end you can also change the unit or anything that you want at the later stage. So our geometry is ready now. uh, First our geometry is ready now, then we will go on to define the material properties to both the domains. So let's say for the materials we will go to the materials, add material, you can type, like, let's say there is a skin. If it's available, it will come. Yeah, so skin is available. So you can just double click on that. Since you are using the transport of dilute species in porous media module, it expects you from you to give the value of the porosity of the tissue that you are. Let's say for the case of the skin, what is the porosity of the skin that we can get from the literature. uh, let's say the initial porosity is zero point 0.1. Also, second material is, let's say there is some polymer. We take any polymer, just type polymer. Let's see if it comes or not. Yeah, different polymers came. Okay, let's say we use PVA, polyvinyl alcohol polymer. See if available or not. Yeah, so you can see it's available here. You can just double click on that. Or what you can do is you can also insert a blank material. Instead of inserting it like this, you can also insert the blank material. Let's say blank material, and for which you can give the properties later also. So so we have inserted both materials. Let's name it patch. Select the geometry, and the skin is already we have chosen. Since porous media is only the this region and not this region, so we only have to define the porosity in this region. Okay, so what we will do is we will give it porosity same as 1, since considering it as to be like completely there is no porosity there. So then you can go into the this physics and see here. You have to give the option whether you want to incorporate convection into your model or not, because since the drug transport through these patches occurs, and it's mostly the diffusion. There's no convection because of there is no fluid flow. It's mostly governed by the drug transport. The drug transport is governed by the diffusion, which is the fixed law, second fixed law. So we will just not click the convection part. In the dependent variable, we will give species. So let's say there is one species which is loaded in the model. We call it C drug. Then after that, we have to give the transport properties in both the domains. So now, as I said, there are two different domains are there. So the transport properties in both the domains would be different. So we will add, there is one porous media which is in both the regions, but we want to give different properties in the patch. So we will add one more transport properties here, and then we click it here. So this is the material. Here you have to choose the material, and which material is that? It's patch and diffusion, and now it asks for you to input the diffusion coefficient into the diffusion coefficient properties. For all these like all the diffusion properties and units, I am not going into like more detail, like why I've chosen 1 into power minus 9 or 1 into power minus 10. For more detail, you can go on to my, because to my profile on ResearchGate or Google Scholar, whichever you like. You can just type Google Scholar, and there's my profile with name of Pratik Yadav. Here there are different. I published different papers in my throughout my PhD, from where you can get the values of drug transport, diffusion properties in different type of tissues and different layers, because your our skin also has different layers. Let's say top layer is stratum corneum, then dermis, then epidermis. So every layer has a different diffusion properties, so you can just get the values from one of these papers. So I'm just more focusing on how on building up the model, not on the values. So let's say just give it a value of 1 to power minus 10. Here you have to give the option of isotropic or symmetric or diagonal based on the directional property of the diffusion. So currently we are taking that it has no directional dependency of any type on the properties. So we will just take it as a isotropic. And then in the porous media, there is this is already selected, and here you have to give the property of the fluid and all. So since fluid in this region would be water, so what we will do is we will add one more material here. We'll add material, go, let's say type water, and take water in the form of liquid. So yeah, we will not give it assign it to any domain. Instead, we will put it here. Let's say fluid. So here it wants you to put what is the fluid materials that is there, whether it's tissue, whether it's air or liquid. So we'll take water as water here, and then it's asking for the diffusion coefficient of your drug in the tissue. So this is again the property this you can get from the paper, and this property depends on the molecular weight of the drug that you have chosen. So if the drug is very big, if the drug is big, you will see it will find harder to diffuse through the tissue, and it will take more time, which I can show you later also, like how the how the drug molecular weight affects the diffusion coefficient. There are different equations, correlations are there that you can use directly here. So, but currently I'm just keeping it some value, let's say 10 to the power minus 30 based on the drug. But just keep in mind this diffusivity would be the function of the molecular weight of the drug that you are choosing. And then, once you have chosen the diffusivity, it also asks you for the diffusivity model also. Basically, since it is a porous media, there are different models for the porous media, because since drug won't be moving straight, it would be coming in a zigzag manner, something like so, let's say I will show you. So because it's a porous media, no, you can expect it to be something like this. So basically, it will take the torch. It's called tortuosity, which will take the path of the drug would transport would be longer than the, let's say that the drug is moving in water. It doesn't get any it flows directly down following the Stokes law, but here it won't be like that. So for that, there are different models are there where tortuosity, let's say this tau is dependent on the porosity that you have chosen to e to power minus 1 by 3. So we will use this. We are currently going on with this model. You can also use the Bringen model. It's just you can go into the literature of this just a dependency, how tau is related to the porosity. We'll just use the uh, tau equal to e power minus 1 by 3 for this case. Now we have defined the porosity here. Let's say porous matrix. So this expect the porosity. So this will take the porosity from the material which we have already defined as a skin here, and then initial values. So initial value of the model that you have to define. So initially the drug concentration in the skin would be 0. Currently it shows both 0. So what we will do, we will add one more initial values here. Let's say initial value, and we will give some initial value to this thing. Let's say give it some 50 molecular weight, 50 mole per meter cube. That mole per meter cube you can calculate based on the volume of the patch and the amount of drug that you have added into the model, which is easy. So I'm just not going into that much detail on that. So we'll give you, like, let's say 50 mole per meter cube. Now this here, it's like the drug, it's zero. And also, like, since once the drug moves from the tissue, from the skin, let's say from skin, it will go into the blood. So basically, once the drug goes into the blood, it it washes away into the body. It's like it's taken away by the blood. So what we will do is we will give one concentration. We will define concentration at the base at zero. So that means once the drug reaches to the base of the tissue, it will just be taken away by the blood. So basically, it's a sink condition. So yeah, so here we have given it the property of this to, we have given the transport properties to transport property to our patch, and given transport porous property to the skin. So that is all. This is just a simple thing to do. We will just go on to the mesh. We can just mesh it. First we can mesh it normal, which shows, like, since the drug transport is occurring from this region here, from the patching to the, so we need to refine the mesh. You can you can do the mesh independent study later, which I will cover in the next lecture. So let's say we give it some property, we define our own property to make the mesh more refined here. So let's say we give it free triangular mesh, and then go to the just wait, yeah, boundary layer. Let's go to the boundary layer, select the domain here, sorry, yeah, sorry, just delete the boundary layer. Got a bit confused because we have to give the finer mesh at this edge, so we will choose edge option here. You can see it here, edge. We'll just move this edge up, select this boundary, and then select size for this boundary. What size you want. Let's say we give it extremely fine. Again, we can just delete this one, and then you see here, you can see the mesh here is more refined now, which is good. And also, like, we want this mesh to, it's a bit coarse at this stage. We want this to be more fine. Let's say fine, yeah. So yeah, so now I think our model should run without any error, hope so. So we have we have defined our geometry, we have built the sketch, we have defined the material property, added the physics, built up the mesh, and now we have to add the study. So since the drug transport occurs with time, so we will be choosing the time dependent study for our model. Let's say we want to run it for, here you have to give the unit for the, for what time you want to run it. Let's say we want to run it for, let's say, take it 1 minute. We want to run it for 10 minutes. After that, just right click on the transport of value species and click on this option, get initial value for step. So this this confirms you, like, you do it before running your model, just to say, like, what unit that you have given, like, in the different domain, whether it's okay or not. So you see we have given 50 moles per meter cube in our patch, which is okay. And there is no drug initially in the model, so that is also fine. So now I think we can move forward and run our model. Since so now, yeah. So here you can see how the duct transport is happening into the skin with time. You see here. You can also click on here and animate it just to see the time how it is changing. So you can see here the drug is slowly diffusing from the patch into the tissue. There are other ways to visualize this as well. You can, let's say, we go the last block that I've shown you know the flux with time how it is changing. You can plot that also. So let's say we we want flux at the bottom, how the drug is reaching to the bottom and how much it is reaching. So you can click on the derived values, get the, let's say, average line average. It will give you average of the drug that is coming to this line. Click select this line and then click on the flux total because it's diffuser only, so you can just whatever you can it will give the same value if you select total flux magnitude to normal flux. Let's say total flux magnitude you select and then plot it. So yeah, so this is the plot. You can also visualize it using the plot, let's say 1D plot group, and based on the table graph. The table, what table was that? It was table 2. Okay, so table 2 plot. So you can see here, yeah, initially for the initial 6 hours there is no flux, since you can also see from the simulation also you can see that there is no drug reaching in the initial stage. That can be because of the low diffusion of the tissue, low diffusion of the drug into the skin, which is evident. So some part of the drug is reaching the was able to reach bottom after 10 hours, so which shows the graph like that. Let's say if we run it for, let's say, just for the sake of the running, let's do it for 240 hours. Let's see what is happening. Game plot line average new. So yeah, now you can see here the flux first it went up, and then after some time it went down, just like the one that we expect in this case also, where like they were studying the diffusion of some, I guess, some permeation enhancer, and like they were looking into how the drug permeation enhancer will increase the drug transport into the tissue. For that, yeah, they got three different graphs. So yeah, so same we also got that thing here. Since if we have the experimental value, we can also add the experimental value in the in this graph, and how to do that I will tell you in the later stage because this video is already long. So yeah, so now this model covers the transport of the species module, how you can use it to model drug transport through skin. In If you have any doubt, you can just comment down, and I will get back to you. Or you can also go through my website if you want. I have other tutorials there, and also like I have different tutorials there. It's in the name of Confusion. The link is in the YouTube description also. So there are different models that I have prepared that you can go through. And also I would be uploading the tutorials for that in the later stage also. So yeah, so that is all for this lecture. In the next lecture, I would be going into more in depth on this porous media module and how you can incorporate use it in other use cases. Like, let's say we want to model the tablet dissolution in the water, how the tablet dissolves in water with time. But like when you eat the tablet orally, you take the tablet, how it dissolves in water and in what time it will dissolve, and how you can model that in COMSOL. And also there are cases like you want to model needle insertion in the tissue, and once you insert the needle in the skin, how the drug transport occur through the patch when it has needles. So these are the other cases that I will model in the later stage. Thank you.